and invite him to start the presentation. The floor is yours.
Test, test. Perfect. All right, thanks. I'm Yannick from Dive Solutions, just said. Happy to be here for my presentation. You'll also see it in a couple of seconds. There we go. So my topic of today is the engineering of construction machines and vehicles. This is one part, and we will talk about cloud-native CAE. Sounds quite complicated, but no worries. It means CAE means computer-aided engineering. So we use software to help you design, simulate those things. I'm ready, hope you too, and let's dive right in. I want to start with a little bit of motivational slide, because if we look at today, never before the speed of innovation was so fast, right? We have 10, 20 years to completely change how construction machines are built. And if you went outside, you saw it, like these huge excavators. Today's key topic is zero emission. So we talk about electrified concepts in the powertrain. And I understand that some engineers might be a bit skeptical, and maybe it seems also impossible to electrify those huge machines outside. Still, I want to be optimistic here, because I mean, it's a very great time to live in. We call it an era for engineers. And as a company, as Dive, we help you develop these concepts faster by removing all limits, all distractions in the simulation process. So far as a quick intro, and I want to show you the status quo. If we say simulation, right, then probably it's nothing brand new. Your companies, your engineering departments, they do simulation. They use it in a product development. And if you look at some statistics, this is from the Aberdeen Institute, you see roughly 30% less prototypes, less engineering time. So cool, right? I mean, I see where people are like, hey, that's okay, right? Why should I now use more simulation? We use some, and we do the rest with experience, like we always did. I think we overlook something here, because just one slide before, I said this is a very unique time, right? We have so less time, we have such large technological steps in terms of electrifying those machines. There are no decades of experience. And that's if you talk more, with the experts and the engineers, I would say they look more like this. Things, that's part of their headache is there are less and less of us, right? We have something like demographic change. We have the same old school tools, software and hardware, but we need to be faster than ever before. And the workflows, I would say, they're also rather boring, rather slow, and all this contributes to their, to their stress. So my question of today, and the reason why we chose this topic, should we now continue doing it that way? Do you think we're able to reach our goals to build zero-emission machines very, very fast? I want to show you a little bit what could happen, right? Like if you continue the old way, and this is why I chose an example. So let's take this very nice case here, like a huge loader. But it could also be, your own mixing machine or anything else you build, kind of in a mechanical product. You have the axles, you have an electric engine, you completely redesign it now to get it efficient. And if you look at the statistics, what typically, as an example, what typically happens is you need like an A prototype, a B prototype, you have a pre-series, you have a series, and roughly 4 years, 4 huge hardware generations to get there. And that's already, although they use some sort of simulation. In my opinion, this is too long, right? Too long, because if you would start today, next bauma in 3 years, you would still have the old products to show and not the new one already. So that's what I want to change. But why do we have this amount of time. The reason is if you look more to what you want to simulate, so what are engineers facing? You have too much, too much varying conditions. You have varying designs, and if you talk about construction machinery, they need to work if they drive up, if they drive down in the desert in Siberia. So all this ends up to these huge numbers to actually, to test virtually as well. And as I said, our experts, they look like this, They're not able, that's not feasible for them to go this far. They have manual workflows. They would need to wait forever for the results. And what happens is that they just select something. So maybe 1 or 2 design changes, maybe 1 or 2 RPMs or speeds, and that's it. The rest, we need to do the old way, like test it, build prototypes to make it sure. And this ends up to the 4 years I was just telling you. The engineer, he could try to change something, right? But engineers would now need to run to your IT department. And I don't want to complain about IT, but they're also getting less and less. It gets outsourced. Maybe you know how it is in large corporations. If they would give this engineer more power, you need more computing power to make more, we need to accelerate our product development, you would end up buying hardware, maybe, but the problem is here, the hardware costs is just a tiny part. What makes up this huge number is what we call or what you may know, the total cost of ownership. So the IT stuff is carrying this huge backpack, maintain it, implement it, customize it, and this is actually the majority of the costs if you look over 3 years. And the IT, they're also improving, right? So engineers, they hear about cloud. Hey, can we also try out cloud in engineering? And an option to make it, I would say, not really better, but to try it out, is you go out and rent your own cloud hardware. That's also what some companies consider. There's a downside because some parts, like some cost buckets, hardware, no electricity, you cut it down. But one underestimates that you need to get an expert, you need to set up this cloud infrastructure for your engineers. There are actually much more updates also, because every time you have a new hardware, you can actually give it to the engineer. So some parts the IT needs to do, they even get more effort. And if you ask the experts, are you happy? Are you happy now with what you got? You have now a little bit more hardware. We use cloud. They tell me something like, hey, I still prefer to work on my own, on my installed software locally, the usability, I have long data transfers, and I think that's already the end of this, my first story. So we started with 4 years of engineering, not being able to simulate enough. There are ways to change it by buying more hardware or by your IT renting hardware in the cloud. And none of them was really like a good way to move on. And luckily, I wouldn't be there if I would now end the presentation. We have a way to make it better, and it's if you use cloud-native software architecture. It sounds fancy, but it's not brand new. If you look to what the other departments are doing, for example, sales and marketing, they are already switched to cloud-native tools. So this is web-based, a browser-based tool built directly in and for the cloud. And we in engineering, we solve some of the most complex things, like complex fluid simulation, and still do it the old way. To give you a little bit of an idea what are these complex simulations for, in this example, we showed before electrified loaders. You would, for example, simulate how is the cooling in the electric engine, right? You would want to increase the power density, get new concepts, but you also have those axles, like the differential, or you have the planetary gear stage. And the engineers here, they want to find out what amount of oil do I really need? Can I use less oil, less losses, less heat. This is what they already try and are finding out with their software today. But as I said, they have to select carefully what to simulate. If you move now cloud native, it means you set this up directly in the web app, in the browser, and it saves you a lot of time. It's much easier, much faster. And in this particular example, you also use a mesh-less, so a particle-based technology. And what we hear from our users, my favorite quote was what I got. He said something like, I didn't simulate it like now for 4 or 5 months, but I still knew what to do, which buttons to click. Like, I didn't forget, I didn't need to relearn the whole software. And I have the cloud now. I have like the full power of cloud. I said before, cloud is, it's bad because your IT has to worry about so much. But cloud native software means that the software providers, so we take care of all the administration, of all the implementation. And there's basically nothing much to do for the IT anymore. On the other hand, your user, he just uses a subscription. So if you've heard of it, this is called a software as a service model. So he just has his, his access like you have a Spotify or a Netflix subscription, and he's more or less independent. So the IT, he doesn't really need to get more power, to get more cores. Everything is on his desk. He can climb this mountain on his own. If we go back to now this simulation scenario, right? Wow, such huge numbers. They're not so scaring anymore. Actually, they become feasible. But the magic doesn't happen in the app directly. It happens in the back end. So my favorite quote of our CTO to describe what cloud-native engineering software is, he says it breathes, like the backend breathes. If you have more demand, it grows, it gets bigger. And as you have less demand, it just shrinks again. So you have like an automatic scaling. And this you cannot build, or your IT cannot build on its own. Otherwise, we wouldn't have our jobs. So this is something, of course, we are experts in doing. And the end of my presentation is now going back to this initial slide with initially 4 years, 4 large iterations. What already our customers are doing with our app is the first version, like the first prototype, is just a virtual iteration. And I'm pretty confident that you can save 1 year and be ready to show us your new product on the next bauma 2025. So this is the end of my presentation. If you want to learn how this could also apply to your particular use case, I'm happy to talk. Also for questions, and our booth is over there. So thank you very much.
Thank you.